Several calculations are needed in order to plan a cross-country flight. Many of the calculations require a flight computer known as an E6B. Both electronic and manual versions of the E6B are available. Online E6B calculators can also be found, but these obviously will not work in flight. Your flight instructor will recommend the right E6B for you. The online E6B will be used during this module for ease in illustration. Your E6B will come with specific instructions for making the necessary calculations. Basic information must be determined prior to making the flight calculations. The true airspeed for your specific airplane can be determined with indicated airspeed information and the altitude being flown. For our flight, we will assume a true airspeed of 110 knots. The altitude flown is determined by the minimum safe altitude for the route and also by FAA altitude regulations. For VFR flights in an easterly direction from 0 to 179 degrees are flown at odd 1,000 plus 500 feet. For example, 5,500 or 7,500 feet. Flights in a westerly direction, heading of 180 to 359 degrees, are flown at even 1,000 plus 500. Since our flight is in a westerly direction, we will fly at an altitude of 4,500 feet. This information is entered into the navigation log. A weather forecast must also be obtained prior to the flight. Wind and temperature information is entered into the navigation log as well. A review of relevant terminology is also important at this point. The true course is the course plotted from the sectional chart. If you remember, for our flight, the true course was plotted at 295 degrees, which is entered into the nav log. A correction for the in-flight wind must be applied, which results in a true heading value. The wind correction value is calculated using the E6B, and the resulting information is entered into the nav log. Because sectional charts are drawn in reference to true north, and we will use magnetic north when flying the airplane, a correction for variance is next applied. The amount of variance correction is obtained from the sectional chart for the area being flown. Magnetic heading is the heading value obtained once the variation is applied. For our flight, the variation is 10 degrees west. This information is entered into the navigation log. Deviation, or documented instrument error for the airplane, is finally applied to calculate the final course heading. We will assume our airplane has no instrument error. Therefore, the heading we will fly to the first landmark is 302 degrees. The speed at which the airplane is moving across the ground, known as ground speed, depends upon the airspeed flown and the wind direction and velocity. In our case, the E6B provided us with an estimated ground speed of 105 knots. The estimated time it will take to reach the landmark is calculated using the ground speed value and the distance to that first landmark. It will take us 5 minutes and 45 seconds to reach that first landmark. Finally, the amount of fuel used to reach that landmark is calculated using fuel burn rate and the length of time it will take to reach the landmark. The first leg of our flight will consume 0.95 gallons of fuel. For the purpose of this course, I have calculated the time and fuel values by hand. You can see the step-by-step instructions for those calculations in an available download. However, most E6B calculators will do this math for you. The same process is repeated for each of the landmarks until the final destination is reached. Please take a few minutes to complete your navigation log and complete the calculations quiz prior to moving on.